G'day, you 10. How you going? We've got another lesson today on simultaneous equations. Today we're looking at the elimination method. So last lesson we looked at the substitution method, where we had to replace one of the values by substitution. This time we're trying to get rid of one of the variables by either adding or subtracting the two equations together. So when we add or subtract equations together, we're simply just collecting like terms. So we're going to add the x's or subtract the x's from each other. We're going to add the y's, subtract the y's, and then add any constant terms as well. What we're trying to do is we're trying to get one of the variables to have the same coefficient as the variable in the other equation, so that when we add or subtract, we eliminate that variable from that equation. And we're left with just one, okay? Because what we're trying to do is, rather than having an equation with two unknowns, we're trying to find one that just has one unknown, okay? That's the goal with both the substitution method and the elimination method. Once you have one unknown in your equation, you can solve it using your traditional methods, okay? Now, this is a little tricky at first, but it can be very simple once we get familiar with it. So it might take a little bit of time to get your head around, but once you do it, it can actually be a much quicker way of solving some simultaneous equations. So it's worth learning. We may need to first, however, multiply one equation so that we end up with this same magnitude of coefficient. So when I say magnitude, I mean you might have a plus 2y and a minus 2y. And then we add those together and they eliminate each other. Okay, if you have the same sign, so it's 2y and 2y, we'd have to subtract one of the equations from the other so that we eliminate. Okay, so if you got the same sign, you're going to subtract to eliminate. If you got the opposite sign, same magnitude, you're going to add to eliminate. Let's do a couple of examples to illustrate what I mean. Again, you might need to watch this a couple of times, maybe watch it and then rewind, pause it and see if you can do it yourself, and then play again to see if you got it right. That may be a helpful technique for you to make sure that you're understanding what's happening here. Okay, so the first thing I like to do is I like to write the equations out one on top of the other. Okay, and I label them equation 1 and equation 2. Okay, the reason why I like doing this is it allows me to visually see what are the details in the question. So what I see is I've got 3x plus 2y equals minus 12, and I've got 5x minus y. So none of my coefficients of my variables match up. I've got a 3x and I've got a 5x. They don't really match up. I've got a 2y and then a minus y. But what I can do is I can multiply one of these equations so that one of these coefficients will match up, at least the magnitude will. So what I'm going to do is I'm going to multiply equation 2 by 2. And I'm just going to multiply every single term. So equation 2 will become 10x minus 2y equals, and then 54. Okay, so what's happened now, the reason why I did this is if I look up at equation 1, I have a plus 2y, and now in equation 2, I have a minus 2y. So what I'm going to do is I'm going to add these two equations together so those y's will cancel each other out and eliminate. So I'm going to add 1 and 2. Okay, I'm going to add this version of 2 that I've just done down the bottom. So what's going to happen is I add 10x with 3x, okay, and I get 13x. I'm going to add 2y with minus 2y, and that eliminates, okay, it disappears. And then I'm going to add 54 with a minus 2, and I get 52. Okay, and you can see straight away, I've now got a really simple equation. My y's have just evaporated, and now I can just divide by 13. Okay, 52 divided by 13 gives me 4. So you see, although conceptually it's a bit difficult, you reduce the amount of working you have to do quite significantly using the elimination method. Okay, now to finish off though, this last part, we still have to do substitution. So I'm going to sub back into 1, sub into 1. Okay, so I replace x with 4 in equation 1, so it becomes 3 times 4, okay, plus 2y equals minus 2. So that equals 12. If I take away 12 from both sides, I get 2y equals minus 14. And then y is not going to equal minus 7. So therefore, x equals 4 and y equals minus 7. Okay, so again, you got to try to manipulate the equations so that the coefficient of one of the variables matches up. Which one you eliminate doesn't matter. You might find y first and then find x. So you can multiply one of the equations so that those coefficients max up. And then in this case, we added them together. The reason why we added is because we had a plus 2y and a minus 2y. Opposite signs, add them together and they eliminate. Okay, let's look at another example here. So this time we've got a 5x plus 3y equals 12. Call that equation 1. We've got 7x plus 2y equals 19. So in this one, unfortunately, we can't just multiply one equation to get the things to match up. What I'm going to do is I'm going to multiply equation 2 by 3, and I'm going to multiply equation 1 by 2, okay? And the reason why I'm doing that is because I want those y's, again, to match up so that they have a similar coefficient. So I'm going to rewrite equation 1 as 10x plus 6y equals 24. Then I'm going to rewrite equation 2 as 21x plus 6y equals so 30, 57. Okay, use your calculator if you need to. Multiply 3 by 19, you get 57. Okay, so the reason why I multiplied the top one by 2 and the bottom one by 3 is so that you can see here, my y's now have the same coefficient. Okay, I've got plus 6y and plus 6y. Now, what I'm going to do is I'm going to subtract one of these equations from the other, so those 6y's will cancel. And because I've got 21x and 10x, I'm actually going to subtract equation 1 from equation 2. So I'm going to go write equation 2 minus equation 1. So it's going to be 21x minus 10x, which is going to be 11x, okay? And then 6y minus 6y cancel each other out, so I don't need to write that. And then 57 minus 24 is going to give me 33, okay? And then I can simply just divide by 11 and I get x equals 3. Okay, so this initial setting up and manipulating the equations takes a bit of work, but then when you do the elimination step, it just magically clicks into gear and saves you a lot of time. Okay, we get x equals 3, and then I'm going to sub into 1 again. Okay, I'm going to use the original equation 1. It doesn't matter which equation you use, all of them are true. So I can go 5 times 3 plus 3y equals 12. Okay, and then 3y, if I take away 15, equals minus 3. So therefore, y equals minus 1. Okay, and then I can write, therefore, x equals 3, y equals minus 1. Okay, so that last step again is the same as the substitution method. Okay, it's just that first part that's different about the elimination method. Okay, now the good news is you can actually choose which method you use. You can always use the substitution method and you can always use the elimination method. The only issue is you need to set those up so that you can do the substitution. So if you do substitution, you have to make y the subject before you then substitute it. Okay, and then for elimination, like we've just done, you need to make sure those coefficients match up before you eliminate. So it's up to you which method you choose, but it's worth practicing both so that you can use both, because sometimes it's much easier to do elimination than substitution, and then other times it's much easier to use substitution than elimination. Okay, good luck with the work today. Let me know if you have any questions, and I'll see you later.